inverse of a matrix. Learning outcomes: compute the inverse of a non-singular matrix using adjoint matrix dengan elementary row operations. Inverse of a matrix, there are three methods to obtain inverse of a matrix. Adjoint matrix, okay, sama ada awak guna adjoint matrix. Use the property AB equals to KI, where K is a constant and I is an identity matrix. And the third one is ERO lah, right? Finding inverse matrix using adjoint matrix. The inverse of a matrix A is given by, okay, this is the formula to use adjoint matrix. So A inverse is equal to 1 over the determinant of A times adjoint A. Okay, where A is the determinant of A is not equal to 0 and the inverse of A is not equal to 1 over A. If the determinant of A is not equal to 0, then A is a non-singular matrix and its inverse exists. If determinant of A is equal to 0, then A is a singular matrix and its inverse doesn't exist. Adjoint matrix for matrix A is defined as transpose of the covector matrix, i.e. adjoint A is equal to covector transpose. Remarks: let A equal to ABCD, then the inverse of A is given by 1 over AD minus BC, and then the covector will be D, negative B, negative C and A. The adjoint will be D, negative B, negative C and A. Matrix A has no inverse if AD minus BC equals to 0. Example 11. So let's use the formula. A inverse is equal to 1 over AD minus BC. So 3 times 4 minus 5 times 1 times adjoint. Then this will be D, A, negative B and negative C. Okay, so refer to this. This is A, B, C and D. So the adjoint will be 4, negative 1, negative 5, then 3. Okay, simplify. You get 1 over 7 here, and then times the adjoint, you'll get 4 over 7, negative 1 over 7, negative 5 over 7, then 3 over 7. Example 12. Find the adjoint matrix of matrix B. Hence, find the inverse of matrix B by using adjoint matrix. So first, we have to find the adjoint. Okay, adjoint matrix. If you refer to the example 8, you can see that matrix B in example 12 is actually matrix A in example 8. It's just the same thing. So we have found the cofactor for matrix A in example 8. So let's just use the cofactor that we found, this one. Okay, so you can refer to example 8, how to find the cofactor, right? I'm just gonna skip that part and straight away use the cofactor that we found before. I mean the one we found previously. So this is the cofactor of B. The adjoint of B, okay, adjoint is actually C transpose, which is 2, negative 4, 4, negative 4, negative 2, 4, negative 5, 2, negative 2, and 2 transpose. Okay, you'll get this matrix right here. Okay, now the second part of the question is hence find the inverse of matrix B by using adjoint matrix. So we have to use this adjoint matrix that we found. Okay, so let's find the determinant first. So B, determinant of B. For the determinant, you can also refer to example 8. Okay, you can see here the determinant is negative 2, since it's the same matrix. So just take the determinant. Okay, just copy it here so that you can see the calculation. And then for the inverse, B negative 1 is equal to negative 1 over determinant, which is negative 2, times the adjoint, okay, which is this matrix. So 2, negative 2, 2, negative 4, 4, negative 2, 4, negative 5, and 2. I'm sorry, I made a mistake here. Okay, there's no negative in the formula. The negative comes from the determinant, so 1 over negative 2. Okay, so then we just need to times everything in the adjoint by 1 over negative 2. Okay, you get this, then this one, next one. Okay, so this is the inverse of B. It's using property of AB equals KI. So properties of inverse matrix, the product of A inverse and A is equal to A and A inverse equals to I, and then A times I is equal to I times A equals to A. Then the inverse of an inverse is just itself, and then the inverse of a transpose matrix is equal to the transpose of an inverse matrix, and then the inverse of product AB is equal to the product of inverse B and inverse A. The determinant of A inverse is equal to 1 over the determinant of A. And then if AB equal to BA equals to KI, then A inverse is equal to 1 over KB, and B inverse is equal to 1 over KA. Given A and B, find AB and hence deduce A inverse. So first of all, we need to find AB, the product of AB. Okay, so 1 times 1 plus 2 times negative 10 plus 3 times 7, you get 2. 1 times 1, 2 times 2 times 4, and 3 times negative 3, you get 0. Then get 0. Second row, first column, you'll get 0. Then you get 2. and then 0. This one you get 0. This one is 0. Lastly, you get 2. Alright, then hence deduce A inverse. So from there you know that AB is actually equals to 2I. And if you times both sides by A inverse, okay, using property you know that this will be I and then A inverse times I will be A inverse. Then IB is just B. And then A inverse is actually 1/2B. Okay, divide both sides by 2. You get A inverse equals to half B. So A inverse is equal to 1/2 times 1, -1, -10, 4, 2, 7, -3, -1. Okay, I'm using this fact, this one right here. Okay, I just substitute B, the matrix B. So times everything by 1/2. This is what you get. Okay, so that's the inverse of A. Inverse matrix using ERO. The fundamental row operations are interchanging any two rows, multiplying any row with a non-zero constant K, adding or subtracting a multiple of one row to another row. So steps for using ERO: form an augmented matrix A augmented I, then apply fundamental row operations to reduce augmented matrix to A augmented A inverse. So you have to focus first you have to focus on this entry, next this one, then 3 and 4, then 5, 6, and lastly you'll focus on the diagonal. Inverse for A by using ERO. So let row 1 equals to A and row 2 equals to B. So this is an augmented matrix. Okay, 1, 3, 2, 5, and then augmented identity matrix. I've highlighted row the diagonal in yellow. Okay, so the diagonal is A, row A. Okay, then row 2 will be B, then the entry. Okay, focus on the entry for row 1 or diagonal is 1, and then for B we have 2. Okay, the one I've highlighted in blue. Okay, 1 and 2. So we're going to change row 2 using this formula: A times 2 minus 1 times B. The first row will remain, so 1, 3, 1, 0. For the second row, that will be 2A minus B. So we have 2A. Okay, A is 1, and then minus B. B is 2. This one right here. Focus on this column. Okay, so 2A minus B. So we'll get 0. Now focus on the second column. So 2A, which is 3, minus B, which is 5. You get 1. Then the third column, 2A minus B, which is 0. So we have 2. Lastly, we have 2 times 0 minus 1. So we get negative 1. So now focus on the diagonal, okay, and the second column. So on the second column, the row that is not related to the diagonal, the one that is not on the diagonal, is row 1. I've highlighted that in blue. Okay, the entry 3. The diagonal is in row 2, so B, and the entry is 1. So we're going to change row 1 using this formula, 3B minus A. I've written the second row because second row will remain. Now let's change first row. Okay, let's change the first row. Focus on the first column. So we have 3 times 0 minus A, which is 1. That gives you negative 1. Then second column, 3 times 1 minus A, which is 3. You get 0. For the third column, so 3 times 2 minus 1, you get 5. And then we have 3 times negative 1 minus 0, you get negative 3. So for the final step, focus on the diagonal. I'm going to change the first row by multiplying it with negative. Okay, negative A. For the first row, it's A, so negative A. So I'm going to multiply it with negative 1. Okay, so it will be negative A. Row 2 remains, and then all the entries in the first row will be multiplied by negative 1. You'll get 1, 0, negative 5, and 3. There you have your inverse for A. Let's try ERO on 3 by 3 matrix. So row 1 will be labeled as A, row 2 will be labeled as B, and row 3 will be labeled as C. So this is the augmented form. Focus on the first column. So you have diagonal, entries on the diagonal, and then row 2 and row 3. So row 2, we're going to change row 2 and row 3. Okay, don't change the ones on the diagonal just yet. Okay, just focus on the ones outside the diagonal. So you have diagonal and R2, and then diagonal and R3. The diagonal will be A, R2 will be B, and R3 will be C. And then just write the entries in the one that I've highlighted in blue. Okay, so for A will be 2, and then B is 1, and then C is 2. So for R2, the formula will be A minus 2B. For R3, that will be 2A minus 2C. Row 1 will remain, so I've just copied it. Row 1 will not be changed. So let's focus on row 2 and row 3. For the first column, row 2 will be A minus 2B, that is 2 minus 2 times 1, that gives you 0. And then second column, you have 1 minus 2 times 1, you have negative 1. Third column, you have negative 1, then you have 1, then negative 2, Lastly, you have 0. Let's repeat that for column 3. So you have 2 times 2 minus 2 times 2, 0. Then negative 2, and 0. And then you have 2, and then 0. And you have negative 2. Now focus on the second column. The ones outside the diagonal are row 1 and row 3. So diagonal is B, row 1 is A, and then row 3 is C. And the entries, formula for row 1 will be B minus negative A, or you can just simplify that to be B plus A. Then row 3 will be negative 2B minus negative C, which is plus C. Row 2 remains, so 0, negative 1, negative 1, 1, negative 2, 0. Let's focus on row 1 and column 1. So B plus A, 0 plus 2, you get 2. Then 1 plus 1, you get 2. Then negative 2 plus 0, you get negative 2. Then 0 plus 0, you get 0. Do the same for row 3. So negative 2 times 0 plus 0, you get 0. Then negative 2 times negative 1 plus negative 2, you get 0. Then you get 2. Next you have negative 2 times 1 plus C, which is 2. You get 0. And then you get 4. And lastly you get negative 2. So diagonal, and then the ones outside the diagonal are R2 and R1. But since R1 is already 0, will not change it. Just let it be, and we focus on row 2. So D and row 2, diagonal is C and row 2 is B, and the entries are 2 and negative 1. So the formula, negative C minus 2B. We are not going to change row 1 and row 3, so just copy them there. So focus on the first column, 0, 0. So you have 0 here, and then 0 and negative 1. So you get 2. Then you have 2, negative 1, you get 0. Then for the next column, you get negative 2, 4, negative 2. So when you get 0, and lastly you get 2. So for row 1, we're going to divide or multiply it by 1 over 2. Okay, so 1 over 2A to get 1 on the diagonal, same as row 2 and row 3. Now this will be 1, 0, 0, 1, negative 1, 0, 0, 1, 0, negative 1, 0, 1, 0, 0, 1, 0, 2, negative 1. As you can see here, after multiplying everything by 1 over 2, you get 1 on the diagonal. So this is the inverse of P. Just state that as your final answer.